first part of the problem is going to involve this part right here. Okay. And when we do that, we're going to see that it really is just a shape like this. And anytime we have a uniform bar, we're going to assume that's the same thing as putting a dot in the center. So there's a dot in the center. So if it's two dots that are in a bar like that, the center of mass is clearly going to be in the center of those along a line between them, this point right here. And let's actually locate it, because the problem actually asks us to locate it. Okay. So that point is going to be dropped down. This side is L over 2. The angle between the two bars, remember they tell us, is alpha. So the angle on this side is alpha over 2. Okay. And this side over here can be located by this. The length of that side is going to be L over 2 cosine alpha. Maybe alpha over 2 down from there. So it's going to be L over 2 cosine alpha over 2 down from this point at the top, the apex at the very top there. Our next one is going to be B, which should be over here. Okay. And again, I'm going to draw that one out. Maybe. Okay, and we're going to represent it as just these three bars, which again are going to be points. And they're all going to be represented as points. And we're going to actually go through and do the center mass equation for these. We're going to call them all the same m, all the same length. So for the x cm, it's going to be, we're going to call this point 0 over here, this point L, and we're going to call it L going up also, just so you have some idea what my scale is going to be. Make a better 0 here. Yeah, I don't know if that's better. Okay. But it's going to be 0 times m plus L, L over 2 times m plus L times m, all divided by 3m, m plus m plus m. Okay, when we do that, we're going to get basically we're going to get 3m L over 2 divided by 3m. That's going to give us L over 2. Okay. So our x coordinate is going to be L over 2. Our y center mass is going to be a little more interesting. It's going to be L over 2 times m. Plus, that's this one here. Okay. Plus 0 over m. That's this point here. Plus L over 2 times m. That's this point here. All divided by 3m. That's going to be L over m plus m plus m. We're going to have ml over 3ml. We end up with L over 3. So our center mass is actually going to be right over here. L over 3 above that point right there. And that sort of makes sense, you know, that it's centered horizontally, but vertically it's going to be a little closer to the bottom dot because the other spots, or I'm sorry, I lied. It's actually going to be L over 3, but that's why it's not going to be down there. It's going to be closer to up here. Draw correctly. It's going to be closer to up there. Okay, not a fourth. It's going to be more like 1/3 up toward the top. So that distance will actually be a little higher, closer to the two dots than close to the one dot. For part C, we're going to take a look at this one here. And again, I'm going to draw that. And then we're going to represent it as 2 dots. It's actually kind of interesting where we end up. You can almost see where it's going to be at. Again, if I'm going to call this 0 and I call this L, then the X CM is going to be 0 times M plus maybe it's going to be L over 2 times M all divided by 2M which is actually going to give me a L over 4. And you can see that it's going to be toward the middle of this. And the same thing's going to happen with YCM. I'm going to end up with L over 4 as well, which is going to give me a center of mass that's about here and there, right here, okay, right in the middle of those. And that kind of makes sense. I think in the key I wrote that it was a √8 from here. And that's correct. That distance should be √8 because it'd be L over 4 squared plus L over 4 squared. Add it, take the square root. The last one is the one that is clearly the yuckiest of all of them. This one right here. And you can see that we're going to have this thing here. And we're going to end up with the points that are going to be here and here and here. Okay. And all the angles are pretty easy. I mean, they're all 60 degrees. 60 degrees. Okay. So we can figure out where all these points are along. If we call this 0, we call this L. Okay. This length over here is going to be what, we can figure that out in terms of L. It's going to be what, this coordinate here is going to be L over 2 cosine of 60. Again, it's not bad, it's sine of 30, so it's L over 4. Okay. And then the other one is going to be L over 2 sine of 60. And that's √3 over 2. So it's going to be L times √3 over 4. So the coordinates of this are going to be, they're going to be L over 4, L times √3 over 4. And the coordinates of this point are going to be 3/4 because we got to subtract it from the other side, and L √3 over 4. Okay. Now, the x coordinate I'm not really going to bother with. I'm going to tell you right away that it's that's something you can actually probably see just by looking at it. I can write it. That's clearly going to be just L over 2. You can calculate that out if you want to see it. It's not terrible. Okay, but you can see that like one is L over 4 to the left of the center, one is L over 4 to the right of the center. They're just going to average out. You can calculate that if you want. But the y one is kind of interesting. Okay, that's going to be it's going to be m times L, come on, √3 over 4. Okay. And there's 2 of those. Come on. One here and one there. And then this one is just going to be 0. Okay, that's all going to be divided by 3m. Again, all the m's are going to divide out. Okay, and we're going to have L root 3 2L root 3 over 12, which is going to be L root 3 over 6. And that's kind of likable too, because that's going to end up being a little lower than this, about there. Okay, not exactly in the center of the triangle, but a little bit lower than there. So we found that point also.